So it's been a while, but it's time to get back to the Saturn 1B. And today I'm going to talk about clustering. So let's get to it. Remember folks, I've been certified to build and fly rockets up to level 3. If you don't have these qualifications, you might want to consider a simpler project and perhaps join one of your local or national organizations. Rocketry is a very safe hobby if you follow some very simple guidelines. Okay, let's go. So the first thing we need to discuss is why cluster in the first place. Well, there are two main reasons to cluster. One is to get more power out of existing engines. So for example, the Saturn V has a 5-engine cluster similar to what we have here. Now the Saturn 1B actually has 8, but there are reasons why I didn't do 8 here, and I'll get to that in a moment. Now the reason I am doing cluster, they don't do this on the real rockets, but what I'm trying to go for here is effect. And in order to understand why I'm doing that, we need to look at the engines that I am using. So this is my engine configuration. As you can see, there's quite a bit here. In the center, I have a single large 75mm motor, and in its first flight, it used an L here. And I have 4 smaller 38mm motors that I use for a low thrust, long burn motor. So talking about what that does, the rocket itself can be flown off of just the single engine, the 75mm. The other 4 are really just for effect. And what's going to happen is this is a very quick burn, so it's only like 2 or 3 seconds long. And that's actually pretty long for a motor this size. And that is big enough to get it up to speed before it leaves the launch rail so that the fins can have aerodynamic effect. Okay, so that's a very important consideration. Now, the outer motors, these burn what's called a mellow yellow. It is a 9-second burn, but very low thrust. As you can see, there's not as much propellant in these as there is in the 75mm. So the intent here is to have a very long burn. So it's actually burning almost the whole way up. It will have some time of coast, but it gives for a very impressive visual. This rocket is not meant to go high. It is meant to be within sight of the crowd who is at the launch that day so that they can get an impressive looking flight out of it. And yeah, so that's why the long burn. Now this introduces some issues. For example, if these small motors light before the larger one, we may not get enough thrust to be stable by the time it gets off the pad. And if this doesn't launch at all, we're going to have a very unsuccessful flight. Similarly, if one of the motors doesn't light, you're going to get a bit of a pinwheel effect where it's pushing on one side of the rocket and the rocket winds up spinning. With a large rocket, that's a very bad thing. So there are some things we need to do to avoid that. What they do on the larger rockets, like the Saturn 1B or the Saturn V, is they actually have a hold down structure. So it holds down the rocket until all of the motors are up to full pressure and we can get a full thrust launch. When that doesn't happen, that's when you get, remember those 1950 films with the rocket sliding backwards, because the engines weren't up to full pressure before it actually lifted off. So we want to avoid that. So what I'm doing with this rocket is the center motor is the primary flight motor. If it doesn't fire, the rest of it shouldn't fire. So this one will be launched by the flight controller that day. When they press the button, this is the only motor that lights. The outer motors are controlled by a timer. And what this does is it detects the acceleration of liftoff, and with a very brief pause, it will then fire the secondary outer ring motors. Now, being a rocket this size with 4 motors, I also wanted to have a secondary timer in case the first one failed. So if this one fired at 200 milliseconds after liftoff, this one would be 400. I can't remember the exact timing I'd use. I'd have to check my notes on that. But that's the basics of it. So by the time the outer motors fly, the rocket's already in the air, it's gaining speed, and is ready for a stable flight. Okay, so solving the problem of making these redundant is one of the things I'm going to be talking about in this video. One of the ways to avoid pinwheeling, I actually alluded to in the video on motor mounts, and I'll have the link somewhere, is to actually angle the clustered motors. And what you want to do is have that angle midway between the center of pressure and the center of gravity. When you do that, instead of getting a lopsided thrust that will push it one way and start the pinwheeling, what you're going to do is you're going to get a sideways thrust. So if there is a mismatch in motor ignition, you're not going to have adverse effects. So that's the other thing I did there. To get redundancy in the timers, I created a simple circuit that I called, simply enough, my cluster controller. And it used diodes to provide parallel paths for the ignition timings and avoid any back current that might have an adverse effect on the other timer. So that's a pretty simple circuit. When I built it, I designed the PCB using an unfamiliar CAD file or a CAD program provided by one of the PCB manufacturers. And unfortunately, the hole sizes that it described for the various components, such as the connectors, were incorrect. So as I was assembling it, pieces just didn't fit. Now, it was on a timeline. That particular PC manufacturer had a very cheap deal for your printed circuit boards with a surprise at the end of the very expensive shipping costs. So I wasn't about to use them again and redesign the board. So I went with what I had. The mounting of the controller, I used this design. So I had my two timers on one side with a battery for each, and the cluster controller on the other side with a battery for it. Now, another feature I added to the cluster controller was the ability to check continuity of the igniters without firing them. That one didn't work quite so well because the switch I had used, the actual switch part, had fallen off. So I wasn't able to check the continuity before the flight. And as it turns out, that was an issue because I had one of the motors fail to light, even with the redundancy. So it is definitely a useful feature. Another thing you will notice here is there's no switches for any of this. I neglected to put that on there when I was making the circuit. So I did super glue some switches to the top. That did not hold very well, and I wound up having to try a repair on the field, which involved, again, super gluing, which would not cure because of the cold temperatures. So there was a bit of masking tape involved. When it came time to mounting the controller, I figured, well, I have lots of room in this section between the two stages, so I'll just mount it here like that. Well, what a disaster that was. So the problem that encountered was the parachute lines wound up tangling with the controller. Now, its function had finished by then, so there was no adverse effect on the functioning of the motors. But unfortunately, it contributed to a pretty severe zippering of the blue tube inside. Now, this stuff, if you've ever worked with it and tried to cut it, you will know how tough this is. But yeah, I managed to zipper it. So I have to rethink how I'm doing this. So on to version 2 of the controller. So this is version 2 of the controller. The controller card is again a custom design. Basically, it's the same circuit that we had previously, but a much better board design. So instead of a 9-volt battery for continuity, this is just going to have a button cell. The timers themselves will still have button batteries. And of course, the timers will mount here. I've added room for switches, and we'll be able to turn the timers on and off. So that'll be done on the launch pad. Now, in terms of mounting this in the rocket, we have to take a slightly different approach. The new cluster controller and mount are going to fit inside one of these fuel tanks. It's not actually a fuel tank here. The only one we use is the center tank, the 38 millimeter mounts, and at the fin can. So we have lots of room to put it in here. The problem is how we get it in there. So this is already assembled. I have a few options. I can just cut out a section, but that's going to have some challenges for mounting. I may try that, but what I am also as likely to do is actually replace the tanks. And there are a few reasons why I want to do that anyway. One of which is the silicon wire that I used as a analog for the in-flight destruction charges, the shape charges. It looked great when I first put it on, but then it flexed and it kind of looks kind of ratty. And that happened within a few hours, so that's not a great effect. I can take that out and take it off too, but then there's the matter of the painting of the tanks. This was done with latex paint. Was not my first choice, but I was in a time crunch and it dried quicker, so that's what I wound up using. I may replace them for that, and just to, you know, you always do a better job the second time. If I do that, then I'll wind up stripping the paint from the carbon fiber on the fin can as well and repainting that. That's significantly more work. Again, I'm not sure if I'm going to do that at this point, but as you can tell, it's going to need some work anyway. So that would fit in here. I'll make a plywood container for that. That will have it drilled in, and then it can be drilled into place. It'll have a cutout over the tank and do the cover. So that's where you're going to see in the first new work that I'm doing coming up is, first of all, populating the cards and then figuring out how I'm going to mount it. If I'm going to replace the tank or if I'm just going to cut a hole in it and see if I can do it that way. So we'll both have some surprises ahead. That's clustering. A lot of challenges to come, but I think it'll make for some interesting challenges. It's definitely a project I want to see go to completion, but there's almost as much work left to do as there was when I originally built the rocket. This isn't even tackling the challenges of structure and forward body section. So a lot of work to come. Hope you're back for more. As always, if you like it, thumbs up and subscribe. Recommend it to your friends. I only need, I think, about 3,920 subscribers in order to monetize. So well on my way. But I do this for fun. That's it. Have a great day.